Hello everyone, today I want to present you our Incubator project's HDF4Water, hierarchical data format for water-related big geodata. As an emerging source of big geospatial data, OpenStreetMap aims to create a free map of the world. And recently, OpenStreetMap have also received an intensive research interest and also become an important source of VGI data in many applications. When talking about OpenStreetMap, we have to be careful about the special geometry models in OSM. There are mainly three major elements in OpenStreetMap, which are points, ways, and relations. Plus also this free tagging schema organized mainly by the volunteers via a wiki document and this default cartography style for the OSM.org. The OpenStreetMap data is indeed informative but can be difficult to use. Therefore, in this project, we have proposed an efficient big data framework for the GeoAI, which is called AtlasHDF. In the past, the OpenStreetMap have mainly two different data formats. The first, XML, which is provides a high-quality, human-readable data format by bridging many barriers in the past, but it's turned to be noisy and inefficient in both representation and parsing. Another data format called protocol buffers, PBF. They are just on the opposite sides. They provide bare data without any flexibilities, but with maximum bandwidth efficiency. Therefore, with the AtlasHDF, we aim to provide a scalable, fast, and immediate access to the raw OSM data. The mapping of the OSM attributes to JSON strings could provide a solution to language barriers combined with easy parsing and tool support, but still with a minimum storage size on the disk. Therefore, at some key design goals for the AtlasHDF. The first is we want to facilitate immediate data use, for example, in the rendering of the OpenGL or with AI models or machine learning models in the TensorFlow and PyTorch. Second, we want to provide this simple and conflict-free representations of the OSM data. For example, we want to avoid the multi-polygons hassles in the OSM. Third, we want to provide a HPC-ready and scalable data format in order to facilitate the future deployment to the large MPI clusters. As a consequence, we built our data framework on the HDF5 stacks with several key features, including the good string support for the B-trees, ubiquitous deployment, elaborate parallel I/O support, and even more. The first step of the AtlasHDF is the immediate mapping of the OSM data. Here, we mapped the three elements of OSM data into a list of tables, where the OSM data was stored in different tables and their attributes were stored as a JSON objects. And at the second step, we design an analysis-ready mapping for the OSM data, where we mapped all the polygons to their Delaunay triangulation format. And this triangulation could enable fast and better rendering because these triangles have a better support in all these rendering machines. Second, it could also avoid the inconsistency of the OSM multi-polygons and the OGC multi-polygon formats. We have tested our AtlasHDF concepts with the OSM data from Berlin, and we have compared our data format with another three representations, which is the PBF, shapefile, and the GeoPackage. As we can see here, by sacrificing the size, we can achieve a lot of nice features with the AtlasHDF. For example, in AtlasHDF, we use this data container concept, therefore we have only one files, and we also have the fast speed of the querying and rendering, And most important, with the AtlasHDF, we have this single and concise dependency only on the HDF5. And this HDF5 is actually a default dependency for even for GDA and for other HPC and deep learning environments. With the AtlasHDF, we can facilitate future application examples. For example, the surface water mapping with OpenStreetMap, the land use land cover mapping, and also the urban 3D modeling using the OSM data and also other data sets. Thanks for your time. Please visit us in the GitHub, and we also provide a promotion video which is freely available in the YouTube. And here is the reference. Thanks. Bye.